The date is 22/5/2020. We are going to see in this video we are discuss about the induction motor, three-phase induction motor. Okay, three-phase induction motor. We will discuss today the three-phase induction motor types, construction, type, construction and principle of operation. Principle of operation of three-phase induction motor. Okay, and concept of sleep. Okay, type, construction, principle of operation of three-phase induction motor, concept of sleep. So I will draw the three-phase induction motor part. Okay, this is the construction. Okay, this is the frame. Here is the winding. Nowadays, the three-phase induction motor are demand day-to-day increase because the 80% out of 100, 80% of in our industry, 80% of three-phase induction motor are used in out of 100 because it has simple construction and rugged weight. Okay, that's mean low weight and self-starting. Okay, self-starting means here is no required for any primary mover or any starter because Faraday's electromagnetic inductions law are start the motor. So it is the one characteristics is self-starting and it have good operating characteristics. Number 4 is low cost. Its construction or structure are simple, so its cost requirement also low cost. Number 5 is absent of commutator. Here is no required for commutator. Absent of commutator. Number 6 is good speed revelation. For this reason, nowadays widely used in our industry of three-phase induction motor. Okay, but constructionally, this three-phase induction motor, every constructionally or every rotating machine have a two parts. One have a stator, second is rotor. As like as three-phase induction motor have a two parts, stator and rotors. Stators are also three parts. Number one is frame. This call parts is frame. Okay. Number is frame. Number 2 is core. Number 3 is winding. Okay. This outer parts call as frame. This frame work as a this frame used for protection this in her periphery from outer side. Also we protect dust moisture from outer side, from the, from the outer side. Okay, this frame also be carry the protect and also be carry the core and windings. Okay, this is the organization of the frame. Then I will discuss what is the org form in the core. This core, this core carry the armature flags. This is the this part is called core. Okay, this path or this field is called core. This core is carry the armature flux. This is the armature winding, this is the rotating winding. This armature flux is provided by the core. Okay, so the carry the armature flux. And then I will discuss the winding. Here is used mainly three winding R, Y, B. That's mean three phase winding are used. R, Y, B. Three phase winding are used. This winding are three phase winding. Three phase winding. Okay. Three phase winding. This winding are connected by the star delta connection or delta star connection or delta or star connection. Okay, mainly squirrel cage induction motor have used the star delta connection. Then I will discuss the rotor parts. Rotor have depend on rotor construction. Motor are mainly two types. Number one is squirrel gauge type induction motor. Second is wound or slip ring induction motor. Okay, this core, sorry, this winding, that's mean this winding are connected by the delta star or star delta connection. Okay, these are three phase winding. Okay, this winding are laminated. This winding are lamination. This lamination are reduce the eddy current loss. Eddy current or remove the eddy current loss. This lamination process are stamping process. This winding are each other separated by the lamination. This stamping are gap standard gap 0.4 to 0.5 mm. Okay, this lamination materials are used the cold rod orient scroll rod green oriented silicon steel. Cold rod green oriented silicon steel materials are used. These materials also be reduce the hysteresis losses. Okay, this is arc of the this is the function of the winding. Okay, this winding arranged and this winding are laminated each other by the stamping lamination. Okay, this stamping lamination reduce the eddy current losses and also hysteresis losses. Okay, this is the construction of the three phase induction motor. Then I will discuss the working principle of the three phase induction motor. So, working principle. This working principle depend upon mainly three laws. Number one is Faraday's electro electromagnetic induction law. Second is Lenz's law. Third is Fleming left hand rules. Okay, this is the vital three rules are mandatory for the working principle. Okay, This working principle, how to work or rotate the three phase induction motor. Here is the supply is three phase supply R I B, three phase supply. This three phase supply is AC supply. Okay, so the this is the vital point for the working principle. Balance phase supply, balance phase supply. A second is space distribution, spatial distribution, winding. That's mean 120 degree apart in space each other. That's mean this winding, three winding supply are 120 degree apart each other. That's mean this is the three phase supply R Y B. They are apart from 120 degree. Okay, so when supply in this starter part, this motor also called as single excited motor. Why it's called single excited motor? Because this supply only supply to the starter part, not to supply in rotor part. Okay, so on side single is supply is to the starter, so it's called a single excited motor. Okay, then when in supply this when in supply in this winding, in this starter winding, there is a um, electromagnetic flux is induced in the winding. How to induce the electromagnetic flux? According to Faraday's electromagnetic of induction law. How to induce the electromagnetic induction phenomena says, according to electromagnetic induction phenomena says that the relative motion between magnetic field and coil induced the EMF in the coil. When supply is AC supply, okay, when is supply in the AC supply, the electromagnetic induction says the relative motion between the magnetic field and coil. There is a produce a magnetic field and the coil induce, there is a induced EMF, and this EMF in this EMF induced when they are supply in the AC supply, where is a produced magnetic electromagnetic flux, and this flux is rotate in this core or in this magnetic path. Okay, here is a present a rotating, here is present a squirrel gauge winding, squirrel gauge type induction motor, squirrel gauge winding, squirrel gauge conductor or fixed conductor in the in the rotor. Okay, rotor conductor in a stationary rotor. This rotor are cutting by this EMF is cut by the rotor. Okay, and this EMF is induced. How to induce in this rotor conductor? How to this electromagnetic flux or electromagnetic field flux is induced in this stationary rotor conductor? This process, the rotating magnetic field, then rotating magnetic field by the this induced by the rotating magnet. How to rotating magnetic field produce? The magnetic field having the moving polarity, the magnetic field having moving polarities is known as the rotating magnetic field. Okay, how is process? Because there is a supply, three-phase supply. Okay, AC supply. This AC supply, AC waveform is sinusoidal. Okay, when it this uh, when it supply sinusoidal or AC supply, this polarity south to north. Okay, south to north, this polarity movement, this polarity will change with respect to time. This polarity will be changed. Okay, this polarity will be changed, okay, with time to respect. So thus the polarity also be changed. So three method will be know for the induce in the rotating magnetic field. The phase more than on, for more than on. Here is three phase is available. Okay, RIB. Number two is equal gap, which types 120-degree apart each other winding. Okay, number three is three phase equal magnetic field. Three phase equal power distribution. Okay, that's mean here is a phase more than on also available, gap are 120-degree apart, and three phase equal supply. Okay, when in this situation is when three criteria are clear, these are produce a rotating magnetic field. This rotating magnetic field rotate in this core or in this magnetic part or in this closed path. Okay, when this rotating magnetic field is induced in this rotor, stationary rotor conductor, the stationary rotor conductor are short circuited by the end ring, and thus the end ring, for the end ring, this conductor are short circuited. Okay, and this current is flowing to the all of the conductor in the rotor. Okay, of the rotor conductor. So thus the rotor are produced a magnetic field, rotor magnetic field. Okay, and here is a present here is a present a electromagnetic flux in a stationary or core path, and here also we produced a rotating magnetic field or rotor flux. Okay, how to develop the torque, then I will discuss. How to develop in this torque, rotor and stator. The developed torque, consider the rotor have only one conductor, the rotor magnetic field link with the conductor, the current carrying conductor when placed in the magnetic field, a force induced on the conductor. That's mean here is the stator. Okay, this the stator magnetic field are rotate in this place or core place, and this is the rotor conductor. Okay, this rotor conductor, this is the rotor conductor. When rotor conductor are, that's mean the rotating magnetic fielding with the conductor, this current carrying conductor, this is the current carrying conductor, when placed in the magnetic field, this is the magnetic field, the force induced, this force induced on this conductor, and this conductor are moved in this path. Okay, when which the direction of this rotating path, this direction is given by the Fleming left hand rules. Fleming left hand rules. Fleming left hand rules means this is the left hand, this, okay, this is the force, this is the flux path and this is the current direction. That's mean any polarity or pole are placed in a, here is the two magnet are, here is the north pole, here is the south pole, two pole are present in a place, here is a current conductor are placed in this path, the flux are flux are flows from north to south and current is flowing in this path and this force is produced in this path to Fleming left hand rules. That's why the rotor are rotate in the clockwise direction. Okay, we see the flux are cut in this rotor station rotor conductor, and rotor conductors are short circuited by the end rings, and these rotor conductors are electromagnetic flux, and when the when the current conductors is current carry conductors, rotors conductors are placed in this magnetic field or magnetic path, the torque are developed, and this torque and hence the torque, hence the rotor are rotated by this torque. Okay, and this rotation movement is direction, and this rotation direction is given by the Fleming left hand rule. Okay, then I discuss how to rotate, okay, this rotor, okay, or three phase induction motor. So we need to Lenz law. Okay, Lenz law says that the cause oppose opposes the effect. Okay, cause opposes the effect. That's mean the rotating magnetic field is the cause and effect is rotating of rotor. Okay, rotating of a rotor, cause oppose the effect. Okay, this is the effect, this is the cause, rotating magnetic field rotor. That means here is the rotor are rotating magnetic, here is the present core, in the core rotating magnetic flux, and the rotor is rotate when that's why there is a produce a relativity motion or relative motion. Okay, this relative motion cause the starter emf. Okay, and this here is the present a magnetic rotating magnetic field, and is the rotor here is the present the rotating magnetic field, here is the present the rotor flux. So this rotor are rotating, this flux also be rotating this direction and this flux direction, and this rotating flux direction, rotor flux direction, and this rotating flux direction are same in the clockwise. So there is a present area relativity motion, but this rotating magnetic flux speed is more than the rotor speed, because because the uh, because the Lenz law cause oppose the effect. This is the oppose of the effect. This rotating magnetic field oppose this rotating rotor. Okay, this rotor rotating. Okay, so here is always present the rotating this flux is this starter flux is always more than the, or synchronous speed always more than the rotor speed. This is the working principle of the three phase induction motor. Then I will discuss the sleep speed in an induction motor. Okay, what is sleep? Sleep is the difference between the main flux speed and the rotor speed of an induction motor. Okay, That's mean here is the main flux where present in the core, and this is the rotor speed. Okay, this difference is called as slip. Okay, that's mean percentile of slip is equal to ns minus nr by ns into 100. Okay, then I discuss slip speed. The slip speed is the difference between the rotating magnetic field speed and the speed of the rotor. That's mean here is the present this rotating magnetic field, this rotating magnetic fields, and this rotor speed. That's mean the rotating magnetic s is equal to ns means synchronous speed of this motor, or n means rotor speed. That's mean motor speed. Okay, this called also motor speed. This is called as a slip speed. Okay, thank you.